Hello again. Today we're going to be talking about differential equations and solutions to those differential equations. So let's get started. Let's say I have a function y equals k e to the negative 4x plus cosine 5x, and I'm told that that's a solution to the differential equation y double prime plus 25y equals 123 times e to the negative 4x, and I need to figure out the value of k that makes that true. So my differential equation has y in it, but it also has y double prime in that. So I'm going to have to take the derivative of y to get something that looks like that, and then take the derivative again to get y double prime and get something that looks like that. So I'm going to take the left-hand side of the differential equation, which is y double prime plus 25y, and plug in my expressions for y and y double prime. The blue part going where y double prime is and the red part going where y is. I'm going to have to do a little bit of algebra to expand those parentheses at the end and multiply those terms by 25. But when I do that, I notice that I've got two terms that they look the same, but one's a plus and one's a minus. So I'm going to go ahead and subtract those out. I also notice that the two terms I have left can be collected as like terms and be 41k e to the negative 4x. And so I'm going to set that equal to the right side of the differential equation I was given. And I notice that I can divide out e to the negative 4x because that's never zero. I've got 41k equals 123. So k would have to equal 3. Let's do another one of those. I've got a quadratic, y equals x squared plus bx plus c. It's a solution to that differential equation right there. But I notice it's got y prime, and y double prime in it. So I'm going to have to find y prime and y double prime, which are sitting right there, just using derivative rules, plain and simple. If I plug those three expressions in for y prime, and y double prime, then that's what the left side of the differential equation looks like. I'm going to expand some parentheses, move some things around, collect the x's, collect the constants. So my left-hand side looks like that with x squared plus 24 on the right-hand side. X squared is on both sides, so there's really nothing I can do to help my solution on that. But if I look at the x coefficients, on the left, I've got 4 plus b, and on the right, I've got 0. I have no x's, so that means that 4 plus b would have to equal 0, making b equal negative 4. For my constants, I've got 2b plus c plus 6 on the left and 24 on the right. I know that b is negative 4, so I'm going to plug that in and solve for c, and I will get that c is equal to 26. So that's kind of how you find some parameters of differential equation solutions. If you have any questions on that, please let me know, and I will see you tomorrow.